It's like an agent driver that can drive all kinds of outdoor machines. Lawnmower is one special kind of machine. It can drive a street sweeper, a pressure washer, or a weed spray machine, or even a snowblower. But at the core, there is an intelligence that drives these machines. Today, it's being supplied by human beings. Tomorrow, it is going to be supplied by this agent.
We're now deeply in the new world of intelligent machines. Today, we'll be speaking with the CEO of Electric Sheep, the first large-scale outdoor maintenance company powered by artificial intelligence and robotics. Starting first with autonomous robot lawnmowers already at 1,000 sites, their strategy is to go big fast, as real-world data is the key currency. You'll be impressed by their brilliant approach to market. Eventually, they see themselves growing to include all sorts of services and all sorts of robots that can automate outdoor tasks that are needed outside of your home or office. It's a $1 trillion market that is waiting for disruption. Nag Murty is an aerospace engineer turned serial tech entrepreneur. Joining me on the second half of this interview will be Dr. Scott Walter, a two-time co-founder of industrial robot companies. Nag, thank you so much for joining me. Been looking forward to this. Appreciate you.
Thanks for having me.
So Electric Sheep is amazing. I'm very, very impressed by it. So many things about it that I really liked. Of course, your business model is something we're going to have to address soon. But you know, this idea that you've already done mass deployment in 1,000 sites because you believe that real world data is what you're trying to capture first. Can you speak a little bit to that first?
Yeah, certainly. So, the key thing for robotics really comes down to data. If you believe in this notion of machine learning eating all of robotics eventually, you need a data engine which can be cranked faster and faster at scale to uncover all the different sort of long tail of corner cases that you'd want your machine learning model to ingest and experience. And so for us, that's like an article of faith that the path to outdoor AI or an outdoor AI agent that can drive all kinds of outdoor machines is by building this data engine.
I love it. And so you've actually, obviously built Verdi, very impressive. It's is it already at this point autonomous? And I know, tell me a little bit more about this world model for nature that you've figured out.
So let's start with like an analogy over here, right? You had these NLP based approaches that were trying to crack language for years, and then out of left field comes, you know, uh, like an LLM like Chat GPT, and all of a sudden, you know, uh, you've sort of solved language at scale in a very impressive way. There's something similar that's been at play in robotics. So if you think about what robotics, was predominantly, it was a classical based approach, right? Where you would map the world, you teach the robot a path in it, and then you'd come up with these sort of rigid heuristics on what the robot should do and should not do. Uh, Now that is being slowly replaced with the LLM style sort of thinking, which is end to end machine learning when it is applied to robotics. So, what that means is you just use either one giant neural net or sort of an architecture of smaller nets that all sort of work with each other to basically ingest a whole bunch of data, and then without rigidly coding rules for these robots to work, they kind of, this machine learning model figures out what to do. So the best way to think about this is, just as LLMs can grok language, you need a model that can grok the physical world. So how do you intuitively move about the world? How do you pick up things? How do you navigate from point A to point B? Do it safely, do it effectively, do it efficiently. Another way to describe it would be to say, call it cat GPT, right? Like your average house cat has way more intelligence than like most robots do today, right? So that's kind of like what we call it internally, and we joke about it.
I love it. Cat GPT. And it makes sense, right? Because the cat's going to move around. It's about the same kind of like, level of the world.
Yeah,
And so your goal is to get 1,000 of these. And you have, well, you have 1,000 sites already. So you have
that's
a
right.
1,000 different versions of it. You're already out there and you just plop it down. And is it like the Roomba? Like it kind of just figures it out? How is this different from a Roomba in terms of course, you're doing, like you just explained, end to end neural net. But tell me how that actually physically works and how it's autonomous.
The way you should think about this is Verdi is a driver. It's like an agent driver that can drive all kinds of outdoor machines. Mowing is one kind of machine, like a lawnmower is one special kind of machine. It can drive a street sweeper. It can drive, eventually like a pressure washer or a weed treatment, like a weed spray machine. All of these things, or even a snow removal machine, like a snow blower. All of these things are specialized tools that humans have evolved over like the past, I don't know, centuries, decades to do a very specific task outdoors. But at the core, there is an intelligence that drives these machines. Today, it's being supplied by human beings. Tomorrow, it is going to be supplied by this agent who we call Verdi, which is basically this agent that has two things, right? One, it has a world model. So it has an intuitive understanding of the physics of the world, like I talked about before. And then, second, it has learned a policy of how to do that task on that given machine, given this understanding of the world it has. And so that's what we call Verdi. And today, Verdi can drive two different embodiments. One of them is a lawnmower, and the other one is basically this two-wheeled self-balancing platform, which is a power tool using uh, sort of robot. And you can sort of show pictures of them, when we or you can show pictures of this on the screen and it'll become more clear to users.
Yeah. Oh, I'll be overlaying that. So I love the way you've been thinking about this, right? So you're not just thinking of one form factor. It's basically this, intelligent agent.
Hmm.
And then it turns out that one form factor is going to be you're going to be mowing today, and
Yeah,
another one is you got this thing that can clip. How do you see the difference between other robot companies, humanoid bot companies that are either doing the home, they're doing the factory? Is that world model that different than your case, which is the nature, right? The outdoors
yeah,
versus Tesla's, who also has cars that are
yeah,
absolutely outdoors and driving.
yeah.
So you think that each of those are completely different world models from each other?
They are, at least like in the initial stages. I think the way this is going to play out is, you have these specialized domains within which you'll collect like an enormously rich amount of data, across sort of the base case and the corner cases that you'll find. And then your models will start to sort of specialize within those data sets, right? So let's talk about Tesla. Tesla is all things on road, right? So they're going to dominate like when it comes to cars. Now humanoids, on the other hand, we believe will mostly find work indoors, just because
Mhm.
that's where the most sort of that's where the most use cases for humanoids are. And then there's everything in between, like the inside of an office building
Yeah.
and the outside, like or the road, right? There's all this vast space in between, right? Which is where you have like our built outdoor infrastructure, our parking lots, our parks, right? Our outdoor campuses, our town squares. Even I would say like our bridges and sidewalks, right? Like all of
Mm.
these things are part of that intermediate space, and we want to focus on building a world model or an agent that can basically drive machines in that outdoor space, right? And what's another interesting point that we've discovered in our industry is that, so indoors, right, the indoor world is very much built around human beings. So I have like these hands that I'll use to grasp everything from like my glasses
Mm.
to my phone, right? And so it's built for really fine dexterous manipulation. But if you take the outdoors, right, if you take built outdoor infrastructure, it's built in service of machines that are largely used to do the work, and it's
Right.
what we call coarse manipulation, right? You're not like threading a needle, but instead you're doing something more coarse, like driving like a mower or like a street sweeper, right? Or like using a power tool to like do something. And so that's really perfect because you now have all these machines already figured out. What's really lacking is that intelligence that you need to add on top of it. And so that's why we picked this problem, because we think it's way more tractable and it's really fast to sort of iterate and crank this data engine to build this model, because we're not really spending time on hardware as much as we're spending time on data collection and building the intelligence if that makes sense.
That makes a lot of sense. So there are so many questions here, but let's go back to the AI first. The AI, are you doing this yourself? Have you partnered with other companies? We had the NVIDIA announce at their recent conference that they partnered with 9 humanoid companies, and they also had a lawnmower uh, kind of thing that was also going around there. Are you partnering with NVIDIA, or are you doing this all on your own? What's your strategy for AI?
Yeah, that was us actually. So
Oh,
Birdie was, yeah, that
it
was
was you. Okay.
yeah,
It
that
was you. Okay.
we had quite a bit of fun taking. So that was not the lawnmower. What we had was, Birdie was driving. Birdie had taken over like this two-wheeled self-balancing platform, and it had like a little leaf blower. And, and what we'd done was we had like a live demo, right? Like we're probably one of the few live robot demos at the conference that
Wow.
was just out in the public interacting and doing its work. So it put like a little astroturf down
Yeah.
at the NVIDIA conference, and we'd invite people to come and uh, throw some
Sure.
debris onto the turf. And like Verdi was programmed to basically keep patrolling the perimeter and then blow away anything that like was thrown in. So that it was a
That's
cute little
that is
demo.
fun. I'd love to
Yeah, it
do that.
was it was a lot of fun. Like, and it was like out there interacting with all the Disney bots that showed up there. It was like a lot of fun. So that
Okay,
was us.
so
But to
that's
answer
you.
your question,
Yeah.
do we have partnerships? Yes. So we work very closely with NVIDIA on their Isaac simulator
Hmm.
because we're big believers in like sim to real. And NVIDIA Isaac Sim is like, a great tool that allows us to train these robots or train Verdi in simulation and then deploy like a pre-trained model onto real world robots. But outside of that, like outside of using NVIDIA Isaac simulator and outside of using NVIDIA computers, or
Hmm.
GPUs onboard our robots, we are completely in-house when it
Hmm.
comes to any other piece of software. Because for us, because again we're going after the end-to-end machine learning based approach, we don't really have as big a code base as much as we have like a really sophisticated ML infrastructure that like cranks this data engine, reviews the data, you know uh, uses that to train the model and then refine. So that can't be done using external tools or vendors. It's all in-house, and it's all in the custom for what we want to do.
Okay, wonderful. Thank you for explaining that. That's exciting. So tell me about your form factor, because I thought it was quite interesting to hear about how you initially started. Obviously the first form factor is going to be some lawnmower kind of thing. You started with the big machines, and then you
Yeah.
realized you didn't need that. And tell me how you came up with this ideas.
Yeah, certainly. So when we started, right, we looked at automating like these existing big, 2,000 pound ZTRs, like, the ones which humans would sit on and they'd, drive. Now, that is incredibly productive and useful, but the big challenge with those machines is that safety and regulations are still unclear, right? When it comes to how do you scale those machines, and then if you have to have human supervisors supervising those machines just because they're so big and dangerous, then that puts limitations on like how fast you can scale. Then we kind of did a rethink on that to say, look, when robots drive machines, they don't really have to be like massive, right? Because you can just swarm like the planet with like millions of these little caretakers, right, who are all going about doing their thing, and they can be really sort of safe, simple, a lot more affordable, because all you need now is like a couple of cameras and like a cheap GPS on it. And because they're smaller and safer, you can effectively scale them a lot faster. So that was the first sort of change in our thinking when it came to deploying machine learning based robots at scale.
Yeah. So deploy, because it's going to be much more affordable. And then you thought volume matters more. Let's go and
Yes.
make a much of this, get it out there. I love the fact that you're already in 1,000 sites. That is already a leap forward to others. I'm sure it's going to be your strategies. Get that out there, get it out there as fast as possible. Who's
Yeah.
manufacturing these bots for you? Are you still hand manufacturing it? How do you plan to actually go scale? If you have how many bots you have today and how many do you expect to have next year and so forth?
Yeah, so today we have about 40 of them deployed across all these sites. So they cycle around like these different sites. We can easily 10x or even 100x the number of bots that we have today because they're very simple for us to build.
Right.
Uh,
Hmm.
because again, if you go back to our thesis, which is we are all about not reinventing the wheel, so to speak, right? There's already all these different outdoor service machines out there that are being manufactured in like the hundreds of thousands. And like they have supply chains built in for them. There's reliability data available for them. All we're doing is we take these machines and just retrofit them with our own compute, right? And our own sensors, and we let them loose. So in that sense, we have a very like it's
Yeah.
really simple for us to scale manufacturing. We're very capex light, almost like relative to other robotics efforts, and we can crank out like hundreds, thousands of these in-house within our own manufacturing setup, which is like really low volume, small scale manufacturing setup.
Like, do you plan to partner with, let's say, Deere and say, hey, you've already making these lawnmowers or these things. Let me go and be the brains. Let me attach it and, go for it. Build it.
Eventually, I think we don't
Mm-hmm.
need them because it's the OEMs are very undifferentiated in our space.
Mm-hmm.
There's like 50 different OEMs who all make pretty much like the same
Mm-hmm.
product.
Mm-hmm.
Like you just paint it a different color, maybe, and like you'll call it a different brand. So for us, it's again like we're very clear about where we want to play, which is data, and then we're agnostic to manufacturers, right? Like because we can basically buy because we're building it for ourselves. We buy these equipment and then we just retrofit it. We don't really need to do anything more.
Okay, I think I'm understanding. So, like, if I need an arm that's a lawn a blow, you just grab one that's out there, snow blower, and boom, I've got the snow blower.
Exactly.
But it's the intelligence. It's knowing when to
Yeah.
blow, where to go, maneuver it, capture that data,
Yeah.
learn, grow. This
Yeah.
is it's one of those things where you wonder why hasn't it been done yet? Maybe it couldn't be done yet until now, with the explosion of intelligence that's out there now. But uh, I'm loving this. So, tell me about your business model again. I know that we've touched on it a couple of times,
Yeah.
but I think that it's important to really break it through because I think you guys are doing something that I've not heard anyone else do. Really,
Yeah.
explain your business model. Yeah.
I think it's very inspired by Tesla in some ways
Hmm.
because what has always driven our thinking when it comes to robotics has been you need a profit making data engine. That's step one, right? Without that, there is no robotics company, there is no AI, there is nothing, right? And this is very true for robotics because unlike LLM companies, you
Hmm.
can't just go buy all that data from the internet today, right? Or you can't just watch a bunch of YouTube videos. The
Hmm.
internet, whatever, over the past 30 years of the internet, you've had like this data of not just human creativity, but human interaction that's been slowly building up. Now, LLMs can just come about and they can just sort of, train on them and boom, right? They've already got their data sources. For robotics, that needs to be built from ground up because you can't train a robot by just watching a bunch of YouTube videos, even if it's first person perspective or whatever, it doesn't work. So, what you need is what Tesla has done, which is you need to build like a business which allows you to deploy robots at scale,
Hmm.
and then you need people to gather that data for you, but most importantly you need to do it profitably. They need to pay you to gather your data as
Right.
opposed to the other way around,
Exactly.
right? And so that's what informs our business model. So our business model really is, at its core, what we're doing is we're saying, look, if data is the most important thing in robotics, then let's just go buy all the landscaping companies out there, right? Let's just vertically, maybe let's not call it vertically integrate because I think that might be confusing to people, because vertical integration in manufacturing means you sort of
Right. Supply
own
chain
like a
knowledge. Yeah.
supply chain all the way
Yeah.
through, right?
Hmm.
In this case, what we're doing is consolidation and
Hmm.
aggregation, if you want to call it that, where we go buy smaller landscaping companies, let's say they're between like 1 million to like 5 million EBITDA. We go aggregate them to build a larger and larger landscaping company with a pan national footprint. So we have like access to all kinds of diverse data, right? Fall seasons in the Northeast, where all the leaves are on the ground. and
Mhm.
then you have like very different kind of grass in like Florida, and you have very different kind of like curbs in Nashville, for instance, and all these are things that we've sort of discovered in our training data. And so we buy all these companies and we just run it like a traditional landscaping services business. So we have a traditional landscaping
Right.
services arm
Right.
that's
Yeah.
that services everyone from like a FedEx to a Costco to like you name it, right? Like traditional enterprise customers today. And then we have a robotics arm, which basically is working very closely with the services arm to say, okay, where can we drop these robots in, right? How do we transform like the operational model
Mm.
that you are using in the services business to best make use of these robots? And then we have this team of, it's a very interesting team because it's this team of PhDs and like engineers who've like built thousands of robots, who've trained at Berkeley, right? Who've done like cutting edge work. And they're like on the ground, hand in hand with these like really
Yeah.
gnarly landscaping dudes, right? Who are like, what
Yep.
is this, right? Like they'll take like a robot that you built, they'll break it the first time you give them, and they'll be
Yeah.
like, take it back, like build it again and bring it back to me. And that feedback loop is another big part of what makes our business model special because
Yeah.
you're not, like the guys building it and the guys using it like talk every day, and they're like on the same truck, like going out to these fields, right? Like going out to these lawns and like
Mhm.
building it together. So that's kind of like what our business model is. And then the way you want to think about like how we want to grow is our we're basically buying up these service companies like generating
Mhm.
all the profits, right?
Mhm.
Using whatever services that they're delivering, generating all the data, feeding that data back into this model, building a robot. Now the use of the robot is twofold, and I want to touch upon this just really briefly. The robot drives differentiation for the service business to go win more business, because
Right.
now you have a services business that's going out to a corporate customer and saying, look, we use robots, we use electrification, and
Yeah.
all our other landscaping competitors are basically still stuck in the dinosaur era,
Mm.
right?
Mhm.
And so the robots drive organic growth for us, and then the robots also eventually drive EBITDA improvements, because as they automate more and more
Exactly.
work,
Yep.
they're unlocking more and more cash flow. So that's our business model in a nutshell, if that
Okay.
makes sense.
It makes a lot of sense. That's why I'm just so blown away by this because first of all, right, you said it's very similar to Tesla, and it's that right now Tesla's testing full self-driving on its, vehicles that customers own, and
Yeah.
they're paying them for it.
Yes.
And so they have a business model that is making money
Yes.
in order to build their full self-driving robotaxi future. In your case, you already have a service that people are
Yes.
paying you. Customers like Costco, FedEx are paying you to provide the service. And then at the same time, it's like very similar to, Tesla with their bots, where the bots going to be used in their own factory. In your case, you've got your bots being used in your own um, service for your own purposes. And so you are your first customer as a
Yeah.
landscaping company to really know. And that's why you're saying these guys are working closely together, because it's really is your business. Then if you can make your business successful, lower cost, even maybe charge cheaper, maybe even have higher services, more services, those kind of things, you will learn all that. I love it. As you can see, I'm excited about product first and foremost, and then I'm excited about business models.
Yep.
And you spend a lot of time studying Tesla, as I have, and you go, how do I build a company like them? So can you just, again, I'm a little skeptical because I've seen Roombas and I've not bought a Roomba, even though I'm
Sure.
such a tech
Yeah.
forward guy. It's tech forward. I've been wanting to buy Roombas. I just don't think they work.
Yeah.
So if they can't even make a Roomba work in a home, and they've been doing this with iRobot for decades, tell me how you're different, that your bot in the lawn can truly do a good job, just like I could if I decided to do the services like mowing my lawn, going the right pathway, making sure that I don't
Yeah.
hit the flower gardens, make sure I don't hit rocks. Tell me why yours is actually effective versus my Roomba can't even do things the way I want it to.
Exactly. And I think it's different expectations here, right? Your Roomba is a consumer product
Mhm.
and you use it, I'd say it's more like a conversational showpiece probably for people who buy Roombas today. Like, the Roomba comes out and like, the cat plays with it or something, right? And the way you should think about like how we're building robots is they're cobots that are meant to improve the productivity of the human crews. So they're tools, they're not products. So
Okay.
so what happens with these robots is, because they're machine learning based, uh, they're not perfect. Like nobody's claiming that they are perfect, but they're good enough to get 80% of any given site done, right?
Mm-hmm.
So as a result, like our crew shows up on a site,
Mm-hmm.
the guy puts down like 4 to 8 of these machines on different
Yeah.
parts of the
And
lawn.
off it goes. Uh-huh.
Off they go to do other things, right? They'll do
Yeah.
trimming, blowing, edging, they'll like
Yeah.
do shrub pruning. And the robots are gonna like very reliably do 80% of the area, right?
Mm-hmm.
With no teaching, no mapping, nothing. Do they leave patches of grass uncut here and there? Sure, right? Do they like not get like all of the boundary today? Yes, right? But that's what the human is there for, right? The human takes care of like the remainder of the work that these guys can't do.
Mm-hmm.
But human plus robot is way more productive and efficient
Then
than human
either
alone,
long. Yeah.
right? And that is true for any machine learning model. They're best deployed, at least at this current state, as co-pilots and not as autopilots completely, right? Where you can just drop them off and pick them up next week. That's really not that's not the paradigm, at least for the next couple of years. But then you can get to the autopilot stage and the only way you can get to the autopilot stage is by going through this stage. There is no substitute, right? You have to build a machine that's 80% good enough, then 90%
Right.
good enough,
100%. Then
then
100%.
gradually
Then
100.
superhuman. That's
Yeah,
superhuman. Yeah.
and then superhuman. Yeah, but then you have to go through this road, right? You have to take this path. There is no productization, right, without like improving your own margins first. And so that's kind of like what we're doing right now.
I love it. Love it. Love it. Oh my God. Okay. So tell me about your company. How many employees you have? How did you raise money? How did you come up with the idea? Yeah.
We are like traditional venture-backed company. We've gone through a few rounds of funding, pre-seed, seed, Series A. We've been in existence for 4 years. Our engineering team is based out of the San Francisco Bay Area. We're all sort of, engineers, PhDs from Stanford, Berkeley, the usual sort of background. And but what's interesting is also that we have a very heavy sort of landscaping operations and M&A talent, and we poach from like the biggest and the best companies in the world. Me and my co-founder sort of complement each other. I come from the technical side. Jarrett, my co-founder, comes from the landscaping side of things. So we've always had this sort of shared vision for how to build this company. In terms of in terms of our locations, we're located across like 4 different states today. Uh, and sorry, 4 different cities across like 3 different states.
Uh-huh.
And we basically service over like 65 corporate customers.
Wow.
And yeah, we've got a healthy pipeline built up of more businesses we'd like to acquire. And so this year we're planning to grow something like tenfold based on sort of the acquisition pipeline that we have, which is
Wow.
great for us because it helps us spin this data engine faster. And our whole goal is to compress this timeline for how quickly we can accumulate the data. And that's really what's driving this. Because if you were to sell a product to a landscaper, getting that data is going to be extremely slow. And like we want to like really like supercharge that process through these acquisitions.
Okay. Oh boy, this is so good. Okay, I'm going to add Scott Walter to join us. Scott is a two-time robotics co-founder. Welcome, Scott.
Hello, Herbert. Hello, Nag. I mean, I've been having a great time listening to this conversation. Boy, there's so many things I wanted to say. I mean, first of all, I love the name Electric Sheep. I mean, that there sets you apart. It's like, it's already you're a winner just for that. And second, your first name is absolutely a classic name for someone who is like kind of working in landscaping because it's a non-ruminator that also eats grass. So it's,
Is that right?
oh, yeah,
It's a
yeah.
British thing from what I've heard.
It's a
Yeah.
horse. It's a horse. Yeah. So
Oh,
it's not a
dag.
sheep. It's a horse. So it's slightly different, but no, it's great. And your business model is also genius. I think eventually they'll probably call it like, the Murty model or something like that in business school. because
The Murty
how to
model.
actually, use that kind of engineer, that interesting flywheel of building everything. So Herbert, I must say is that like, I was an early adopter, unlike you, of the Roomba, and also a late adopter. So I had like all sorts of complaints about it early. I still have lots of complaints about it. And I think one of the main differences is I've seen earlier also some automated lawnmowers out there, which you probably know that they've been around
Sure.
for, I think, almost 30 years. They almost were like a Roomba that would
Yeah.
went around your yard, and they were really slow, and they were just a glorified weed whacker on
Yeah.
wheels. And that's part of the problem. And that's the problem with the Roomba. The Roomba is not a vacuum cleaner.
Yeah.
And then this is where Nag has it right. He's talking about taking existing equipment that already does the job right and automating. What Roomba did is it said, we're going to completely change the vacuum cleaner. We've got automation. We're trying to figure out how to stuff a vacuum cleaner into it. And it
Yeah.
does, the suction is horrible. They
Yeah.
try to be a jack of all trades. They try to do the edging and all, and you can't. And I find that what the Roomba does, I have to do everything that I don't like do about vacuuming. And it does the one
Stairs.
part that I enjoy, which is the wide open things. So what you've got is you've got a machine that actually cuts the grass the
Right.
way the grass is supposed to be cut. And that is the big difference. That's the key difference. And why, the Roomba really has to be a vacuum cleaner that's able to move
Yep.
itself around, not whatever this other thing is. Because when I'm using it around here, I'm cleaning up after it. It goes over carpets and it creates lint. It's like, what? The wheels are like creating all this other lint. So
Yeah.
anyways, I kind of go on. So the couple of questions I have for you is like, obviously safety was a big concern.
Yeah.
And so I'm wondering, with this, what's the size of the mower you have? What's the speed? Is it comparable to traditional mowing? Because my understanding is you're using like normal blades. You're not doing a weed whacker.
Yeah. Yeah. So the size of the mower today, it's a 25-inch platform.
Oh,
So it's basically a 25-inch push mower that's been retrofitted to drive around. Um, it's got a couple of different like safety modes associated with it. One is it's got like 360 sensing, right, using a couple of stereo cameras that are on it, and then it's also got like a bumper that can sort of physically, that's sort of the last fail safe. But really, it's primarily vision based, and I'd say it's like 99% vision based as a system, and we rely very heavily on sim-to-real training to sort of pre-train our models, and then we also end up doing a lot of fine-tuning with real-world data. And stereo vision is a big part of like what drives the safety case too, because we're not as sensitive to things like classification as much as we are to geometry, and so we're very driven by like geometry when it comes to our safety.
yeah. Now, if I think about the traditional kind of landscape equipment, the popular mower is what I call the UFO, because it kind of looks like that. And I
Yeah.
think it might be at least 48 inch or more, but I don't think it's a big diameter 48 inch. It's probably
No.
a
These
couple of
are
blades next to each other.
That's
Right.
right. Yeah.
So that makes me wonder. And the thing is, those things can zip along really quickly.
Yeah.
And one of the things that's about it is that they're really good at making almost like a fine dust so you don't have much trimmings. And I'm sort
Mulching.
of wondering, could you do like a convoy mode with your mowers, is like basically put them next to each other and just go along there and have one behind there or something to get, because the clippings is like, that's
Yeah.
also a potential
So
problem. Yeah.
most mowers, right? Most commercial mowers do what's called mulching, like which is
Yep.
what you're referring to as like pulverizing things to a very fine mist, and that's true regardless of whether it's a big mower or a small mower. It all depends on like the power of your motors and the
Mhm.
blades, like the design of your blades.
And
So
keeping the blade sharp.
yeah, you got to keep the blade sharp. You got to have like high turbulence generating and lift generating blades, so the clippings stay in the air longer for them
Right.
to get whacked like 3 or 4 times before they fall down. So that's kind of like how you realize mulching. So again, like we're not reinventing the wheel there, right? Like our goal is to not build mowers. Our goal is to build this AI driver that can drive everything. So these things have already been figured out by commercial manufacturers. So
Mhm.
we take the best commercial mower out there in our weight category and in our size category, and we just automate it. We're not getting into the business of building a really good mower ourselves.
Yeah, I'm just wondering if you would be in a way of like almost like a better approach to cutting the grass. Like, if you have the fleet, usually when I see the pros doing it is they cut my grass twice, right? They go
Yeah.
on the diagonal pattern. And is there a more efficient way to be able to do it? Of course, the other things that they're supposed to do is that when they come near a sidewalk, if there's pedestrians there or a car going by, you need to stop so the debris doesn't come out and hit them. So I
Yeah.
imagine you've got a lot of safeguards for that as well.
Yeah. So it all depends on like whether you side discharge the grass or you sort of discharge it downwards. And so we picked our model to or picked our mower models that can like dump the grass down as opposed to like blowing it off to the sides. You should also be careful near water edges, near a pool and stuff like that. You want the clippings to go over there. And we also run them slower and as a swarm, to your point, right?
Hmm.
They do go as a convoy, but we're not as big on striping, which is kind of like an interesting insight here. Like you talk to a lot of like commercial customers, commercial landscapers, and they think like all their customers care about is like nice straight lines and stripes. Turns out that that's maybe true for like 5% of like the really prime properties out there, but 90% of the properties, right, commercial properties that we focus on, they just want tall grass made shorter and they want it done like efficiently, right? So for us, it's really about sort of not so much geometrical precision as it is in terms of like robustness and completeness and doing it safely. So we don't deploy these as a convoy, more as a swarm. And like these robots will sort of be dropped off at different parts of the site and they'll sort of finish it up and they'll all return to home and be
Right.
wait and
So,
they'll wait
so
to
you
be
can
picked up.
so you can still do it timely because that's part of the reason they're zipping along and going really quick is because
Right.
they're also very time sensitive
Yeah,
that they want to get my lawn done in 20 minutes as
that's
opposed
right.
to the kid
Yeah,
down the street that's going to take 90 minutes.
that's right.
They have that's the only way they can be profitable. So if you have the swarm, you can do it to match what the crew has to do all the other trimming
That's
and
right.
blowing and everything
Yeah.
else. Yeah.
Exactly. And small machines are way better because they give you a much better finish of cut. Like they don't scalp your grass, scalp the ground as much. Right? So there's a lot of little
Yeah. Well, the other
details.
thing is a really big mower has like really big wheels, and so you
Yeah,
almost end up making ruts after a time.
that's
So
right.
if you
Yeah,
have them going around, your lawn almost like you say has a more natural look.
that's right.
The
Yeah,
people want the
exactly.
striping is because they want it to look like the football field that they go to watch the kid play their football game.
Yeah,
That's
yeah.
the main reason why.
Yeah, yeah, exactly. And we can get to it eventually, but again, like that's the best part about running these internally, right? And like we plan to deploy these at scale. Like you can truly decide what features are really important and what which are not, and you can really prioritize, your development and your R&D towards things that will make you money, like quickly, right? And that's kind of like number one rule for us as we build
Ah,
robots.
yeah, here's one thing is the problem that almost everyone has with landscapers is that the edging and trimming kind of causes a lot of damage to your landscaping,
Yeah.
to trees, to lighting, to the barriers, and of course to your sprinkler heads.
Yeah.
So, are you really good at avoiding the sprinkler heads, or are you GPS mapping all the sprinkler heads to make sure you really miss them?
No, our goal as a company is we truly believe that the only way to solve robotics is not through pre-mapping or you have to be able to do this job just as a human would, right? Pushing a push mower. So it's purely vision based, it's purely semantically aware thinking, right? On, so the way we've trained it to avoid things like sprinkler heads is through is basically by having like a lot of simulation work done, right? Where you're simulating like all these different conditions. And then it basically, when you put it on a robot, it knows how to avoid those areas. Does it get them wrong from time to time? Sure. But that's kind of part of the reinforcement learning process, right? You want these robots to go out there, you want them to make mistakes. And that's the only way they're going to learn. And that's another big reason why, this sort of uh,
Mhm.
like vertically integrated or consolidated business model makes a lot of sense.
Mhm.
What are the other form factors that you're going to do next? So you're very focused on lawn mowing at this point. You've got 1,000 sites. You're going to grow 10x maybe by next year. All still with this one form factor, or are you expanding to others?
No, we have multiple form factors already at work today because our goal is to build like this agent that can drive all kinds of machines. It just so happens that mowing is the first use case we're going after,
Yeah.
and that's easiest to scale quickly and get us a lot of data. But
Hmm.
you've probably seen on like our on our social media posts, there's a two-wheel self-balancing thing called
Hmm.
which has like a blower and a trimmer, and that's
Hmm.
something we're in the process of rolling out later this year as well.
Hmm.
Going forward, we have like the ability to generalize across all kinds of outdoor service machines, And so that's really what what we're focusing on: surface coverage and course manipulation. Those are the two broad categories of robots that we want to automate over time.
Yeah, no, now this is sort of interesting. Is you originally you were talking about taking original equipment that was designed for human to push, which are
Yeah,
basically self-propelling anyways, and just
yeah,
adding intelligence to it. So you didn't have to do very much. But
yeah,
I haven't seen a leaf blower that's able to like move itself around. I mean,
yeah.
so now you're having to design a bit more to what's there, which is now taking sort of another step because you can only take it so far. And I have to say, I really liked your thought process that earlier on I was, writing something like, oh, he should say it. And so, oh, wow, he actually said that. And that we've had this discussion all the time on Herbert's channel with people asking, it's like, well, why the humanoid bot factor? Why is that? Why don't you have all these others? And we're going to say, well, it depends upon the use case.
That's right.
And I think you've really come up with really good use cases that there are environments that are designed for humans
That's right.
because we occupy them. So everything has to be for it. The last time I checked, a bridge wasn't really designed for a human. But
That's right.
certainly when it came to like the maintenance, the bridge was designed to function as a bridge to keep the stuff up. And it was like, well, later on we'll figure out how to maintain it. And it's like it's really hard to do that. And like you say, you have special equipment. So when we start looking around and start seeing, it's like, well, I mean, do you want the humanoid out there just with these clippers and going like that the whole time? Yeah,
Yeah,
that's one way to cut the grass, but that's very, very inefficient. The main thing is to look at it and then to ask a question, well, is it more efficient? Is it efficient to have the humanoid push it or
yeah,
just make the thing do it itself? And so,
right.
yeah, that's where you're going to see that space. And I think what everyone is looking at is they're expecting the bot's going to have like this different form. And they don't realize the form already exists. All
That's
you're
right.
doing is taking
Exactly.
the thing that's already there and giving it intelligence. So that's absolutely brilliant.
That's exactly it. And you know what's there's two kinds of tasks. If you want, I want to go back to this, right? There is surface coverage, or like let's call it like 2.5 degree surface coverage, right? 2.5 dimensional surface coverage, where you're going over. It's not like flat like surface coverage like a Roomba. It's like the outdoors is way more complicated, right?
Mhm.
It's got these dips and valleys and like hills to climb, right? And it's got like these divots in the ground that your wheels can get stuck in. Like it's a very hard problem. Like make no mistake, right? So it's a very interesting problem. So that's 2.5D surface coverage, and there's what we call coarse manipulation, which goes back to this notion of leaf blowing and trimming, right? It's not fine in the sense of threading a needle, which is what a humanoid needs to do, right? But it turns out that there are like really good form factors, pretty robust form factors that are available today. Like for instance, like the one that you can see in our videos is a self-balancing Segway, like two-wheeled sort of self-balancing thing, and it has a lot of degrees of freedom
Mhm.
that is more than enough for it to get a lot of course manipulation work done, right? And those are like super cheap to build. Like you don't all the motors exist, right? Like the battery technology has been figured out there. So both 2.5D surface coverage, like snow removal, power brooms, mowers, and then the coarse manipulation tools like welding like a shrub, like a hedge trimmer or a leaf blower, both of those things have already got very robust embodiments already, which is why we want to stick to those two. Anything else which requires you to like have fingers, right, or like have like 6 DOF, 7 DOF arms, having played with like arms, like it just like we don't think the tech is like there any is going to be there anytime soon. Like maybe 5-10 years from now, like when humanoid like the humanoid form factor has been made commodity by like all the Chinese companies out there, I think that might be the right time to come in and like start layering on the software. But we have to start with the building blocks. It kind of goes back to like Elon Musk's sort of plan, right? He's like build like the first thing and then use the profits from that to like bootstrap the next thing and then the next thing. So there is a ladder for us. This is the ladder. You want to start with the simpler machines and then climb the ladder to the more complex machines, if that makes sense.
Yeah, that makes perfect sense. So I'm thinking about this. So if you put a leaf blower on a Segway, you do have kind of a lot of degrees of freedom there, maybe more than people expect.
Yeah.
But I'm wondering whether you're kind of using one of them unintentionally. Obviously, I can get my leaf blower to point in any direction I want.
Yeah,
But I like it to go up and down. And one way I can
can do
make it to
that
go up
too.
and down is literally make it lose its balance, and then
No, no,
and
no.
then correct
That's a
it.
really good point,
But
right?
and is that enough of a degree of freedom, or do you actually have to add a little bit more to make it really be able to go further up?
That's a really good point. So this is not, think of the second platform that we have is not quite like a simple two, like a Segway. A Segway is just like two wheels, right? Like there's
Yep.
a left wheel, a right wheel. But there are other sort of platforms out there. Like if you look at like the Ascento robot, for instance,
Yeah.
the outdoor security guy, the way that's also a very it's a very simple hardware form factor where you have like two wheels and then you have on each joint you have two motors, so now you have a total of six, right?
Mhm.
Three in each three on each sort of side of the symmetry, and that allows you to sort of have like a really if you sort of play out like the full range of motion, it's really versatile, right? It can like dip up, dip down, it can like turn around, and it can also go at this weird like angle, right? And that's really cool as it moves up hills. Like you can see it almost like stabilize itself as it like maintains a level, but like the wheels will be in different orientations. So it's surprisingly versatile for what we want. And then I also come back to this other point, which is if it allows this robot to do 90% of the work, there you can build like millions of them, right? And the
Mhm.
more tricky stuff where it requires like a guy with like a leaf blower to go into like the remote part of like your shrub or whatever that you can't reach with this guy, so fine, he'll just do it using like a you know like you'll do it using a human being. There's no need to automate 100%, you
Yeah.
know in
You're going
this
to need
industry.
the human being to kind of supervising anyways. And
That's
while
right.
they're supervising, they may well take care of a couple of the simple tasks. Yeah.
Exactly. Yeah. Who's going to charge these robots? Like, who's going to like, take them to the site, right? Like, full automation is maybe 30 years out. But again, how do you bootstrap your way to
Hmm.
like that
Mhm.
end state? And that's the most
So,
important thing.
Nag, are you? You said a little bit earlier that you really are about the
It's
brains and the
it's a great
intelligence.
business model, and uh,
Sorry,
Yeah.
Nag. Earlier, you were talking about the brains and all that. Is it fair to say that you turn on and you go, oh, I'm this form factor today, and the next time it's I'm this form factor, and I figure out everything. Is it the one? Is it one thing, or is it going to be a different brain for each of these different form factors?
Freaky Friday.
No, that's a great question.
I don't know.
I know, like, yeah, people exchanging bodies and all that, right?
Sunday, wake up. Whoa.
Yeah. So the way to think about this is, so it's kind of like how we can hop into different vehicles, and we're like, okay, now I get like this. It's this snowmobile, so I'm gonna have to like adjust for latency when I like drive, right? I can't make sudden movements. I'm gonna skid. So what that is fundamentally, what we're doing there is two things, and we have an analogy on the robot as well. There's a world model which you refer back to, right, when you make these decisions. So that world model models the physics of the world, and that is common across all machines, right? So that's one way to think about it. And then that world model, when it gets put on a specific embodiment, let's say a snowblower versus a mower, it learns a policy that's very specific to that embodiment. So it's not like you can just take that and put it somewhere else. What you'll have to do is you develop that one core model and then you fine tune it to learn policies that are tied to those specific embodiments, if that makes sense, right?
Mhm.
Much like you teach someone how to drive a car and then also drive like a snowmobile. So it's the same thing at work, but 90% of it is the same, if that makes sense.
Mhm.
Yeah,
What did
it
you?
does,
Mhm.
because if you think about it, when you're riding a bicycle or driving a car, they almost become an extension of you. They
That's right.
additional embodiment. And everyone talks about, oh, I can feel the road through the steering wheel. And it's like, you kind of
Exactly.
can in a way. So you do have that sense that suddenly becomes part of you. And
Yeah.
you notice it also when you pick up something like just a water bottle and close your eyes. I mean, it's kind of part of your body because you already know where the tip of that water bottle or the hammer. I mean, it's always those
Ex-
kinds of things that suddenly your body is able to extend into those things. So I could see the same thing with your embodiment is like, I have a basic function understanding the world. And now you put this thing on me and it's like, oh, well, now I've got like skates on. I'm now a figure skater as
That's
opposed
right.
to running shoes. I'm going to do something a little bit differently. Yeah.
That's right. So you have like that one core thing, and then, but it's not like you can't just like remove it and suddenly, like in 2 seconds, it's ready to run something
Hmm.
else. It has to be sort of, uh, you take the core and then you sort of mold it into these, and then every improvement you make to the core translates obviously, right, to all of these machines. But then there's also a fine tuning that's policy specific that has to be done at the level of the machine. There is no way to decouple, you know, I don't think we're anywhere close to building a truly general agent that's like AGI for outdoor robots. I think
Mhm.
it's more, yeah, like sort of this two-part sort of solution that we're.
What do you find to be the hardest problem that you're focusing on right now? Like when we spoke to Brett Adcock, CEO of Figure, he
Yeah,
was surprised that actually that the hardware is now still the rate limiting step because he was shocked that the AI has actually progressed much faster. For you, is it your business model? Is it the hardware? Is it the AI?
I think it's, right now we're basically, it's just how do you get these things out there like as fast as possible, and like crank the data engine faster and faster, because the hardware is very commodity, like we've talked about, right? It's not hard for us, right? uh, the the software, I would say, is just a function of data. And so then the only thing you really have to solve for is data, because data writes itself, right? At the end of the day, like,
Yeah.
you have to get out of its way and let data do the work. That's how we sort of look at our challenge. How do we
Yeah.
scale this as soon as possible?
Right, because again, your model is so different, which is awesome. You buy the hardware or you retrofit it. This it doesn't have to be perfect in the AI like the others do, and it's
Yeah.
already doing useful work now, and so you can already sell it and make money. So it really is just grow and then everything just improve everything at the same time as fast as you can. But you don't have to because you already have useful work. Others
That's
are
right.
still
Yeah.
trying to get their bots to do useful work.
Yeah,
Hmm.
you don't have to justify. Like a bot has to earn its right in the world, and like, to sort of make sense. And you want to start with like bots that have earned that right, to sort of exist alongside humans. And humans
Do you
become
have?
creatures.
Yeah.
Yeah.
Do you have any pushback from any customers? Is there a customer says, no, I want you to have your humans there. I don't want you to replace it with bots.
Not really. I'll tell you what's really interesting about like enterprise, and we don't do residential. Like we're
Mhm.
purely enterprise. It's like a $300 billion commercial market, like even without going anywhere else. And then the broader market is like $1 trillion, but like just commercial is a massive space. And commercial customers don't really care. They're like, I don't care what you do, right? As long as you know, like you get like the work done. They do care about things like noise pollution, so they actually love
Mhm.
the fact that our equipment is all electric and very, very quiet when it comes to sort of doing the work. But the automation itself, like, they just want work done quickly, efficiently, cheaply, and like, yeah, like, that's really all that they care about. Like, for them, this is robots are a means to an end. um,
Yeah, that brings up a good point. Is around where I am, they were thinking of passing an ordinance that all the landscapers had to use only electric equipment
yeah, yeah,
because it seems like not everyone gets the grass cut the same day of the week. It's like it's going through the whole week. So you're always hearing someone out there with a leaf blower, and those things just make a racket all the
super
time,
noisy,
as
yeah,
well as they're kicking up a lot of pollution as well. And
yes.
and of course, the argument was that it'd be very difficult for them to be able to do the recharge because they're just using a lot of power. Are you able to find a good strategy? I assume the strategy was just like battery swaps and a few other things like that, and a lot of your equipment, um, and that you probably charge at night, or are you charging on location?
Yeah, that's a great point, right? Like the part of the problem with automation is also to figure out how do you build all that other infrastructure around the automation, right? And again, Tesla is like a true visionary here. They built this charger network. They figured out a lot of these things. And robotics companies need to figure that out too. So the way we approach this is, when we buy a company, we have to figure out how do you restructure its workflows and like its sort of vehicle utilization to say, okay, how do you rejig like a vehicle with like charge points, right? And like an internet sort of data port, such that all the robots can stay inside the vehicle, and then all you do is pull the vehicle back into the yard, like at the end of the day, and you plug in like a power cable and you plug in a data cable, and then like you're ready to go again the next day. So figuring out that infrastructure is actually a huge part of what it takes to make robots work at scale. And that's what we find really interesting. It's these little boring operational details which we love like getting our hands around, right? Because that's the difference between like a robot that's truly good and like a science project. And I think
Mhm.
like, yeah, like we spend a lot of time thinking about like these little things on like how to make them better every day.
Well,
um
even to the trailers that you bring on site, that would be rather interesting to see because
yeah,
usually you go in there and you'll see on the walls will be a lot of the extra equipment, and then there's like room for maybe two mowers to come in there. But
that's
you're looking
right.
at it, it's like, well, wait a minute, there's a lot of volume in there, and so it's like, that's because a guy's got to be kind of riding that thing up there. But now if it's completely autonomous, you could have different shelves that you could put a lot more mowers in there, right, on one trailer, as well as
Totally.
any battery packs. I mean, you could have power walls in there. Anything else? I'm not sure how good solar would be able to help in a situation
Solar is
like
not great for
that.
this because I mean, solar, yeah, it doesn't like charge as quickly as you want it to.
Yeah,
Uh,
maybe enough to keep some of the smaller equipment going, but probably not the mower itself.
Yeah. What we have, I can like share pictures
Yeah.
of like our truck. We love it. Like we've spent hours trying to optimize it, like, on like the right form factors, the right locations for the equipment. So we figured that the economic unit has to be this truck, right? Which is not like a traditional F-250 pulling like a trailer, right? What this is basically like a box truck, which has like a rack, like an array of like these little robot mowers and other robots sort of that get stored in there along with like the traditional handheld equipment because they go alongside humans. But then you also have to take into account things like how quickly can you sort of unramp these machines and like get them out there, right? Because time is money again in these situations, right? So you can't like have like the guy just going back and forth, every time to like deploy like a swarm of 8 robots. So how do you solve for that? Like how do you design the ramps to be like,
Mm.
pulled out quickly, put them back quickly? All those little details which most people would not associate with robotics, we take very, very seriously because for us that's the difference between like a good
Mm.
robot and like a robot that's useless.
So you
uh,
don't have a trailer at all, a landscaping trailer.
no, we
It's a
use a
single truck.
box truck to
Oh, that's
deploy these
cool.
robots. Yeah,
That's okay.
The bots are self disembarking. They just drive out by themselves.
that
You
would
got to
be
get
cool
there.
someday.
That'd be cool.
It would be really cool if like Tesla makes like a truck, so now the whole thing is
Called the
automated.
Cybertruck. Yeah,
Yeah, yeah. So the thing
got
like just
power on
drives up
board.
to a site and like out comes the robots. That'd be really cool. Yeah.
Oh my god! So what's next for you guys? When did you last raise money? When are you going to raise money next? You said you might actually 10x. When are you going to make these decisions?
So we're in the process of figuring that out this year. So we last raised money about 2 years ago, and we wanted to perfect the technology and the business model before we start to go out and raise again. So we're basically poised to do that over the course of the coming quarters, because we've got like a lot of what's interesting about our industry is that a lot of the landscapers love what we're doing and they really want to come and partner with us
Right.
because they're like, hey, I want to work with you guys, roll over my equity, like part of my equity, right? So they'll sell their company, get some cash, put in
They'll
some
be your
equity,
investors.
right? Yeah,
Interesting.
actually, a few of them are already invested in us too, so which is
Yeah.
really interesting. So they want to roll over equity, and then so we want to kick off a movement where you have landscapers all over the country who can really sort of gain in the upside as well as help sort of collaborate
Yeah.
with us and drive this revolution with us,
Mm.
right? And that's really most like really important to us, and so that's what like we're hoping to do over the coming years, and we want to do that 10x from where we are at today this year.
Sure.
Another brilliant thing, right? They're not your competitors. They're your
No.
No,
partners.
no,
Yeah.
Brilliant.
they
Yeah, we're all
absolutely are.
brothers on the road to AGI, right? Like we're all going to
Yeah.
get together and like make this
Not
happen.
not the landscaping companies. They're not.
No,
But
no,
now
that
they
I
now
can
they
see
are.
that if you were a landscaper, you trying to figure out what your client base at the beginning of the year, and you're making a huge assumption about how many people you can hire
Yeah.
to cover
Mm.
those needs.
Yeah.
And then you do that, and suddenly there's shortfall in there. And I know this personally from the landscaper. He's a great guy. He's out there Saturday nights at 10 o'clock because he's having to do it all because he was like short one or two landscapers.
Mm.
And
Exactly.
then he gets it ramped up, and then Labor Day comes around, and suddenly, boom, they're all back to university. And suddenly,
Exactly.
once again, he's shorthanded. So it's really hard to figure out where am I going to get these resources, where to get these people in. And he just would like to be able to say, can I take on 100 clients this year? Or is
Exactly.
it going to have to be 50? And if
So
he
it's
knows
another,
every year I can
yeah.
do 100 or 150 clients because I've got reliability, they
Totally.
will love this. They
Yeah,
will.
you
And
hit the nail on the head. It's
yes,
such a labor constrained market. And these guys, landscapers are the true entrepreneurs, right? We love them because
yes.
they're the backbone of like, small business, like businesses like landscaping, right? Are what
Mhm,
make America great at the end
mhm.
of the day, right? Because they're out there, they built bootstrap these businesses from like zero to like 10, 50, 100 million. And now they're struggling to grow because they don't have labor.
Yeah,
So, why not just like join forces and just like build like a massive company this
yeah.
way, right? Solves everyone's problems.
Thank you so much, Nag. Appreciate your time here. So you can follow them on website. It's called sheeprobotics.ai. You can follow them on X at Sheep Robotics. I love it. Love it. And then you can follow Nag Murty as well. Thank you so much for your time. This was eye-opening, brilliant model. I think just your, well thought out approach to everything is what's going to help you succeed. Failure will help you grow, but get out there. And that's what you're doing. Get out there as fast as possible. Love it. Hope you guys succeed. Appreciate you. Hopefully we'll be able to do follow-ups and see how you're doing. Thank you so much, Nag.
Absolutely. Thank you so much for having having me over, and like thank you for allowing us a chance to tell the story and hopefully sort of share what we've learned. And yeah, would love to come back and tell you how we're doing later
Thanks.
on as well. Thanks again.
Bye-bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.